So this is Gracie from IT. My topic is about beyond blocks, syntax and semantics. Beyond blocks, syntax and semantics. The terms syntax and semantics are fundamental concepts in the field of programming languages and linguistics. Let's explore each of these concepts and discuss their importance in programming languages. Syntax definition. Syntax refers to the set of rules that dictate how programs written in a particular language are structured. It defines the combinations of symbols, keywords, and other elements that are considered valid and meaningful in the language. Importance. Proper syntax is crucial because it ensures that the code is well formed and can be understood by the compiler or interpreter. Syntax errors occur when the code violates the rules of the programming language, making it challenging for the computer to interpret and execute. Semantics definition. Semantics, on the other hand, deals with the meaning of the code. It defines the relationship between the syntactically correct elements of a program and their intended behavior. Importance. While correct syntax is necessary, it doesn't guarantee that a program will behave as expected. Semantics ensure that the program executes in a way that aligns with the programmer's intent. Errors in semantic leads can lead to logical errors, where the program runs without syntax error but produces incorrect results. Beyond blocks in syntax. Modern programming languages often extend beyond traditional block structures. Example, if statements loops to incorporate more flexible constructs. For example, languages like Python and Ruby use indentations to define code blocks instead of explicit braces or keywords. Some languages introduce syntactic sugar, which provides more readable or expressive ways to write code without changing its underlying meaning. This can include features like list comprehensions, lambda expressions, and more. Beyond blocks in semantics. Advanced programming languages incorporate sophisticated semantics to enhance expressiveness and enable more powerful abstractions. Features like closures, first class functions, and metaprogramming allow developers to write more flexible and reusable code. Domain-specific languages (DSLs) often have semantics tailored to a specific problem domain, making it easier to express complex concepts in a concise and natural way. Concurrent programming models and languages provide semantics for dealing with parallel execution, ensuring that programs can effectively utilize multiple cores or processors. Beyond blocks, functions and procedures. Syntax describes how functions or procedures are declared and invoked, specifying the order and types of parameters. Semantics defines the purpose of the function or procedure and the effect it has when executed. Object-oriented concepts. Syntax encompa- encompasses classes and object declaration, method calls, inheritance, etc. Semantics specifies the behavior of objects, how inheritance is implemented, and how methods interact with object instance. Concurrency and parallelism. Syntax involves construction for creating threads, processes, or other concurrent entities. Semantics deals with the execution order, communication between concurrent entities, and potential conflicts. Domain specific languages DSL syntax tailored to a specific problem domain, often with a specialized vocabulary. Semantics reflects the meaning of the construct in the context of the targeted domain. Web development syntax HTML defines the structure, CSS the presentation, and JavaScript the behavior. Semantics determines how the web page looks, behaves, and interacts with users. Natural language processing NLP syntax involves the grammatical rules governing sentence structure. Semantics concerned with understanding the meaning of words, phrases, and sentence. Machine learning models syntax describes the architecture, layers, and parameters of a model. Semantics specifies how the model learns patterns, makes predictions, and generalizes to new data. Understanding both syntax and semantics is crucial for effective communication and problem solving in various domains, not just limited to traditional programming constructs. Whether you are designing a programming language, creating a DSL, or working with complex systems, considering both syntax and semantics is essential for clarity and correctness. In summary, while syntax and semantic forms the foundation of programming languages, advancements in language design often go beyond traditional block structures. Modern languages aim to provide more expressive syntax and powerful semantics to make code more readable, maintainable, and efficient. Syntax analysis versus semantic analysis. Syntax analysis process of analyzing a string of symbols either in natural language, computer language, or data structures conforming to the rules of a formal grammar. Semantic analysis process of checking whether the generated parse tree is according to the rules of the programming language. Syntax analysis parser performs syntax analysis. Semantic analysis semantic analyzer performs semantic analysis. Syntax analysis second phase of the compilation process. Semantic analysis third phase of the compilation process. Syntax analysis takes the tokens as input and generates a parse tree as output. Semantic analysis checks whether the parse tree is according to the rules of the language. Syntax analysis generates a parse tree. Semantic analysis generates an annotated, annotated syntax tree. Thank you.